Welcome to today's webinar. The topic today is soil structure interaction in Rfem 6. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the German and English webinars, technical content of the website, customer projects, and so on. I will be the moderator today and I will answer your questions during the webinar. My colleague Juliane Stopper-Akdag will be the presenter. She is responsible for the development of the add-ons concrete design and geotechnical analysis, and she works also in the customer support team. Okay, then I say some words how you can ask questions. At first, I switch off my camera that you can see the full screen. Just press the button with the question mark, then enter your question in that field, press send, and then I will receive your question and I will answer you. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, that's for the moment all from my side. I hand over to Juliane. Juliane, it's your turn.
Okay, thank you, Andreas, for the introduction. Welcome also from my side to our webinar today for geotechnical analysis add-on. We now will go to the first slide, and here we can see the content for today. For today, our main block, the main topic for this webinar is soil structure interaction with using the advanced half-space method. In Rfem 6, with add-on geotechnical analysis, we provide, on the one hand, the finite element analysis for soil with the specific and advanced soil material models. And on the other hand, we provide the advanced half-space method for simulation of, for consideration of soil structure interaction. And this is what we will have a look at today in detail. After that, I would like to show you a new feature that we provide for concrete foundations add-on. We will have a look at the different ways that are provided for this add-on to model the soil for the geotechnical design of the foundations. And that will be it. Afterwards, we will just have a short outlook on the next development steps for our add-on geotechnical analysis. Okay, then that's it for the content. And now I would like to directly go to Rfem 6, to our program. Yeah, here we can see the building that is provided or prepared for our model today. We now will work on preparing the input for the advanced half-space method. We have here a concrete building with walls, columns, slabs, and loads are prepared too. We have some loads as example, and now we can go to the geotechnical analysis. The first step is that we need our add-ons, so we go to the base data, and here we can see the add-ons, and we should switch on the geotechnical analysis. I will do it, and with activating the add-on, the required input or provided input options and calculation, and also the output options for geotechnical analysis are integrated into the main program. Yeah, and the first step we start with is the materials. We have to define our soil materials, and therefore we go here and we say, let's create a new material. Yeah, for the advanced half-space method, especially, we would like to recommend that you use a material from the library as start material, and then you can modify the material properties. So let's go to our library. Here we can see different materials, and we will now, for example, take this sand, I will just take one of them, as we anyway will give the input for our material that was found and described in the geotechnical report for the current project. Okay, we have here material type soil, and we have the option user-defined material always active, so we can directly start to modify the values that came from the library. If a material comes from the library, we have this register material values, and this is why we would recommend to use it, because here you have some more input values for soil property descriptions, and especially the odometric modulus or the constraint modulus is mentioned here, is can be used for the advanced half-space method. This modulus can be also expressed by, or is related to the modulus of elasticity and the Poisson's ratio. So that's why we also have connected them with the equations. For example, if we give here another value, then we will see that our E modulus will change, and on the other way around too. Yeah, and the Poisson's ratio you have to directly give, and the modulus of elasticity and the constraint modulus, they are calculated with the other one and the Poisson's ratio. Yes, and now I would like to give the input for our model today. So the first layer for me is a filling, let's say, and we will give the input. It's filling 1, and we have an E modulus of 50 and a specific weight of 17 kilonewton per meter cubic, and here we have the saturated weight of 20.5. So this is our first layer. Now I can copy it and create my second. Here I have an E modulus of 85, so I will provide it and give my specific weight, which is 18.5, and the saturated weight, which is 20. Okay, then we will come to the next layer. It's yeah, kind of clay soil. I will call it clay, and it has a lower E modulus of 17.5, and we give the specific weight. Here it shall be 18.5, and we have the saturated weight, which is 21, and then we come to the sand 1. It has an E modulus of 90, specific weight of 17, and the saturated weight of 21. And then we will come to the final material we will have. It shall be 100 E modulus, specific weight is 18, and the saturated is 21. Okay, then we have all our materials prepared, our soil materials, and we can save it. So to sum up, you can decide whether you want to give the constraint modulus, because in geotechnical reports it is common to provide the constraint modulus, or you can also provide the modulus of elasticity. Both input options you can use. Okay, we save it and close, and now we can see here our material is here. It is not in use yet, that's why it's shown in blue color. Okay, yeah, then that's it for the materials. Here we have we are in the folder for the basic objects, so we find here cross sections and thicknesses of the building and yeah, other structure objects. Now we will go to geotechnical objects, and these we can find here in the geotechnical analysis folder. And we will start with the boreholes. So I go here and say create a new borehole. The borehole can be used to give the information about the soil stratigraphy that was found by the tests and is described in the geotechnical report. You can directly give this input here. You can give the position where this soil stratigraphy was discovered, and then you can give the soil layers and so on. Here we also can give a groundwater layer. So let's say we have here 2 meters, and then we can give the soil layers, and we start with putting the materials that we just defined. It's the right row, let's say, and then we can define the thicknesses. And the first layer has a thickness of 1 meter, the second layer has a thickness of 2 meters, then we have 1 meter of clay and 11 meter of sand 1, and we will give another 16 meter for sand 2. Okay, so this is the soil layers that were found or discovered below our building. We can say okay, and we have our borehole here, and we can also see it, display it, so that we can see it graphically. This is our navigator for display, and here we can find also the boreholes, and we can see it is placed here now. The boreholes you also can find in the table, of course. We have here the structure, and here's geotechnical analysis objects. And here you can also fill borehole data, the coordinates, and you can also use the export and import for this table. This just is small info beside. Yeah. You of course can define more boreholes, but we for today will just use one. Yeah, it is shown in previous webinars how to model this with more. Okay, and then we can now go to the soil massifs. I do a double click so we get to the dialog for new soil massif. Here we can assign the boreholes that shall be used for this massif. And here we have definition type for the soil massif, and we have boreholes set. So this means the soil body, let's say, will be defined with using the boreholes. We will see. It will generate us the layers, and yeah, I will show you afterwards, but we go on with giving the input. Here you have the selection of the soil representation type, so how our soil shall be modeled in this analysis. And we have, as I said, as I mentioned before, we have the finite element analysis provided for soil, but today we want to use the advanced half space method for consideration of soil structure interaction. So this is our representation type today. Here we give the position of the soil massif. So we will place the center at -10 meter. It's roundabout in the center of the building, and the y direction shall be in -8 in global coordinates. Okay, then we also give the dimensions, and it will be 47 meters in A direction and 36 in B direction. And we will also use the groundwater generation, so yeah, it will consider groundwater. With activating the advanced half space method, we got here this special settings tab, and here we give further input for this method. Here we have to select the surfaces that shall be supported. I will select them. I have 2 surfaces. Now they are assigned, and yeah, it is prepared. We can see here on the right side that our advanced half space method will generate vertical springs, and here we have horizontal springs, and these are the default values. We will keep them for our webinar model. The automatic detection will be provided, and here we can see what will be generated. We will generate the surface support, and we will also have a line support to consider the soil next to the slab, and it's the support by the surrounding soil and also the shape of subsidence. Yes, we will have a look at this later. Here we can find further options. We can activate that we want to consider failure under tension for the generated supports, and this option here is for simulating or considering a rock beneath the last layer, which will bring that there below the last layer that we defined in the boreholes, high stiffness is considered, very high. Yeah, but we will not use it in here. So we keep the settings like this, and we go on OK, and we will see what is happening. I would like to not see that groundwater surfaces. It is not needed, so we deactivate it. Okay, so what do we see here? Also, I want to have this transparent mode, and we go to the navigator for display and switch on the types for surfaces and types for lines. Okay, now we can see here our building with our foundation slab, and we can see the lines of the soil and the soil layers, and we can see that here some supports were placed, and we can have a look at them. We can see them here. They can be found here in types for surfaces. Here we have our surface support. We will do a double click. This color means that it's a generated object. We can also see here with this button, we can see that it is connected with the parent, the soil massif. So it was generated by the soil massif. And here we see our horizontal springs that were defined, and all the other values, the vertical spring CUZ and the shear springs, they will be generated for every finite element with the advanced half space method. And we can see that we have here our nonlinearity, our failure of tension contact for stresses where are there. Okay, then we can leave this and also have a look at our line supports. They are here, they are also generated, and yeah, we can see that we have the failure here too, and here the ZUZ will be generated. Okay, we have a small workaround in the current state. If you just want to have the advanced half space method with just producing you the surface support, it is possible that you can here assign a manually defined support, for example this one, and give here a small value. For example, and you can assign it to a line here at the boundary. Then this support will override the generated support, and in this way it's also in the current state already possible to just have a surface support here. This is just as short hint. No, I don't want to apply this. Yeah, it is planned in the future that we also will provide that only surface supports can be generated. Just as small info beside, but in the current state we have surface support and the line support. Yeah, one more thing, we can go back to the soil massif. I want to show you. If we go here in this setting, we have in our dialogues generally we have here this button, and you can, if you want to know some of these settings you don't remember, maybe what did it mean, you can go here to our online manual, and here we provide information for this dialog. It is linked to here, and we can also see that there's an information about the supports that are generated for this method. We have here surface and line, and you can also go to the background chapter to see the equations that are used in this method. And we are now here, elastic half space method, and here we have a description and also the equations for ZUZ and for shear springs, and also for the line support are provided. Just as small info beside. Okay, then we can go back to our model. We are here. Yeah, and we can leave this dialog. So now our geometry is prepared. We can see here, and we can now go to the loads. As I said, load cases are prepared, but we will go here to our dialog for load cases and combinations. We want to use in this webinar the combination wizard, so we want the program to generate the required number of load combinations. We can use here also the sen. Okay, and we use the combination wizard and the corresponding load combinations. Okay, here we have our loads. I will change the action category because I just switched, I changed this national annex, and now my action categories are lost. We will correct this. So I have here, let's say these are office areas. Yeah, then that's it. So I can show you the load cases here. Okay, so we have a self-weight load case and live load for the roof and for the floors, and this load case was came for the it came from the activation of geotechnical analysis add-on. It is needed for the 3D finite element analysis, but for advanced half space method we don't need it, so you can just delete it. It will come that this will be only generated for the 3D analysis, but in the current state it is also generated for the advanced half space method, which is not needed, so you can just delete it. Yeah, so this is the load cases that we will use. Okay, then we can go to the actions, and here we can see our action categories that exist in our model. Then we have here our design situations, and they are also lost. I want to have this and quasi-permanent. So we have ultimate limit state and serviceability limit state for characteristic situations and quasi-permanent situation. And here you also can see the combination rules according to the selected standard that will be used for the generation of the combinations. For the combinations, as mentioned, we use the combination wizard. It is an object that collects all the settings that have an influence on the how the combinations shall be generated. So they are collected in here. And I have for all my design situations the same wizard assigned. Here we can see our action combinations, and then here the load combinations. And yeah, so the program did generate all the combinations according to the standard with the load cases I have. Yeah, so about the advanced half space method, it is an iterative method for being able to consider soil structure interaction, and this method is the same that was provided in Rfem 5 and was named Säulen. So we have this here, the advanced half space method is called in Rfem 6, and this in Rfem 6 will be done for every load case you solve or for every load combination. So this default behavior. So if you calculate any combination, it will just use the advanced half space method, and it will calculate for every load situation, for every combination, the corresponding foundation coefficients. Yeah. This is the behavior. In Rfem 5 it was like this, that you had to select one combination, and for that you did calculate the foundation coefficients. In Rfem 6 we have for every combination the option to solve the advanced half space method and calculate foundation coefficients. But it is not needed for more complex structures. It can be yeah, it can have a bigger influence on the let's say performance, and also it is not required to calculate this interaction for every single combination, especially for ultimate limit state with the safety factors. It's not making sense too much. So we have an option provided to decide which combination shall be solved with advanced half space method and which combination is not needed to be solved with it, and will use a support from another combination or load case. I want to shortly show it here with an example. I just copy this combination so we can see it, yeah, to show you. Here I have a combination, and we have here these special options, and here we can see import elastic support coefficients from. So what is happening if I activate this setting here? This setting causes that for the current combination the advanced half space method will not be used. Here the finite element analysis will done with the support, the surface support and also the line support that come from the solution of the load case or combination that I select here. For example, if I say now I want to have here the quasi-permanent situation with load case 1 with self-weight, I want that the advanced half space method is done for this combination. Then we have surface support for this combination, and for me it's fine. It's well enough solution if I use for this combination CO13 the support from that. Yeah. So this is the option to set whether a combination shall use or not use the advanced half space method. Okay, I will delete it. It is not needed to do it manually. If you use the wizard, you have also this setting in the wizard, and I want to show you. So we go here to our design situations. Here we have the combination wizard. We can go here, and here we can see we have in options 2 also the option to say that the elastic support coefficients shall be imported for the combinations that are generated with this wizard. And then we can see here the special tab opens up. And here we have two different options to do it. The first option is that we just select one load case or combination. I want to now select the load case self-weight. So this will be assigned, and we click OK, and I will just show you what's happening. I just use apply, and now if we go to our load combinations, we can see that for every of these load combinations, I have the load case 1 assigned as defined in the wizard. With this definition in the wizard, it was decided that all these combinations will not have the advanced half-space method used. They will overtake or take over the foundation coefficients from that load case. You could also, of course, define different combination wizards, or you could also say quasi-permanent I want to solve. You could, for example, copy this and here not have it. For example, then this would not have the, I also have to set it. So then here this setting is not active, just as an example. Okay, now I want to show you another option. We again go here to the wizard. I want to present the second setting here to you. Here you can go on corresponding load combination, and you can select a design situation. I will select now quasi-permanent. And what is done here, we will just check. So I select here the quasi-permanent, and it means that the elastic support coefficients will be taken, so the surface support will be taken from the corresponding load combination of design situation quasi-permanent. So we will have a look at it. What does it mean? We go here to the load combination, and now we can see that for my combinations I have this setting switched on, and I have here a quasi-permanent situation assigned. And we have here this register where you can see the corresponding combinations. Corresponding combinations for design situation, for each design situation. And so this means the corresponding combination for CO1 is CO9. It also has load case 1 assigned. If we go to the next, we have here in this CO2, we have the load case 1 and 2, and the corresponding quasi-permanent combination is this one. And because of that setting in the wizard, this one will be assigned to that combination for taking the elastic support coefficients from. And we can see it is done for every combination. And for the quasi-permanent situation, it is not activated, because the program understands, or it was programmed like this, that of course you cannot assign the quasi-permanent situation for itself, and it also, we don't want to assign something here. These shall be calculated with advanced half-space method. So with this setting in the wizard, you can select a design situation that shall be solved, and assign these supports from those to these combinations. Okay, now we are prepared. We have prepared the loads too. One small more setting I would like to present. We have here the static analysis settings. These collect the settings that have influence on the static analysis. And here we have the special folder geotechnical analysis, and here you can find for our advanced half-space method the control for the maximum number of iterations and also the precision of the convergence criteria. This just as a hint again. Okay, now we are at the point where we can start the calculation, and we will do it. I do a click on here and say calculate all, and our combinations will be solved. So yeah, here we can see now that at first our quasi-permanent combinations are solved because these have the supports that are required for the other combinations. So we can see how the program does its job. Okay, in the time where the calculation is done, I would like to show one more slide. So we go back here and do a click here, and oops, this was too far. I just prepared the slide to summarize a bit the procedure that is done now. The advanced half space method is able to consider the soil structure interaction via these generated spring stiffnesses. So we have these surface supports and line supports, as we had a look at, and these are influenced by the soil properties, so the material, the stiffness, and also the layers, and by the load and the geometry of the founded slabs. Or the foundation slabs. And the method is like this. It is also summarized here in that flow chart. We start with our structure, and we have a start value for the foundation coefficients, and for this model the finite element analysis is done. Then we have for the whole building and also for the foundation slab, we have stresses and strains, and below the foundation slab we have contact stresses. With these contact stresses, the advanced half space analysis is started. The contact stresses is put as load on the subsoil, and the stress is integrated layer-wise, and with the stiffness of each layer, the sediments are calculated, and also the foundation coefficients. At first sediments layer-wise, and then the total sediment of all layers together, and then the foundation coefficients are calculated. Then these foundation coefficients, they go here to the model, and our surface support and also line supports are updated. And then the next finite element analysis is started, and we have new contact stresses as the stiffnesses were different a bit. And then the convergence criteria is checked. Is it fulfilled? Then we would be at the end, we would have the final result. If it is not fulfilled, another advanced half space analysis would be started with the updated contact stresses. They again will be put on the subsoil with its properties, and again the sediments will be calculated, and also the foundation coefficients. Then it will be updated, and so on and on, until this iterative process is finished and the convergence criteria is fulfilled. Yeah, this just as small summary for this method. Then I would guess that our analysis is done, and we can go back to the model. Yeah, here we can see it. Now we have results. I will go on the wire view, let's say, and we will have a look from the top. So what is displayed here? We see the elastic support coefficients CUZ, and we can have a look at them here. Here we have our surface results, and this is now for the combination number 1, the foundation coefficients. And as we know, this support was taken from actually the quasi-permanent situation. We can also switch to the corresponding, and we will see it doesn't change. for detailed infos, we can also look at the values on surfaces. So here we have results more in detail, and we are now in the quasi-permanent combinations, and we can go to the next one, and now we can see that the values change. The values change because of we have different load situation, and there we can see that the soil structure interaction is considered. If the building is changed, if the load in the building is changed, also the soil reacts differently. And if it would be the same if you would change something in your building, remove an object or also add one, then also the soil would react different. And this is the advantage of this method. It is able to consider this, the dependency of the soil reaction to the loads and stiffnesses in the superstructure. Yeah, so this here we have CUZ, and we also have the shear support coefficients. We can check them, and yeah, this is it for these foundation coefficients. We can switch off the values on surfaces, and we can also have a short look on the line supports. We can see them here in the support reactions, and here we do have them. Yeah, we can switch them off again, and we can also place result sections. There we have this button here where you can select from which node to which node the result section shall be positioned. And I already have prepared 2 result sections, and I can activate them here, and I can see results for this sections. I also can display just one. And for these sections, we can also go here to result diagrams and see more the result in detail. Now I see that I should change my section a bit. I can go into it, edit it, and I should here not assign all. And I will select only this slab surface, which is here. Okay. And now I can show you the result diagram. So, and here now you can see it more in detail for this result section. We can see the stresses and the deformation, and also we could have here the where is it? The support coefficients. Here we have the elastic support coefficients. It was already active, and yeah, you can see contact stresses and so on. Yeah, these you can also print to print out report for detailed documentation. Okay, and of course we can see you can see the deformation also here that occurred because of this load situation and how the soil reacts to it. Yeah. So yes, this is it, what I wanted to show regarding the advanced half space method. So in Rfem 6 it is possible to consider this iterative method for soil structure interaction consideration for as many combinations as you wish, and we also do this iterative procedure for every single finite element. Yeah, then that's it. Okay, this shall be enough for introducing this method. Then I would like to go to the foundations, as I told. Therefore, I have here a model prepared. I will show. We have it here. Yeah, and I want to also show you the slide as short introduction. Yeah, as I mentioned, we have a new feature for our concrete foundations that I would like to introduce today for you, to you. We now have for concrete foundations, for the geotechnical design, different methods to define the soil layers. We have therefore the type single layered, where you can directly in the dialog for the foundation define the soil layers, relatively simple and quick, and yeah, this is a fast way of direct input of the soil situation. If you have below the foundation a layered soil and you want to consider this and define it, we provide the option to use the borehole dialog. For the add-on concrete foundation, the borehole dialog is provided too, so there's no geotechnical analysis add-on needed for using this solution. There you can go to the borehole as we showed for our advanced half-space method, define the soil layers and assign it to the foundations and use it. And then the latest option that was released is that you can use the soil massif. For this solution, the concrete foundations add-on and the geotechnical analysis add-on should be active. And there you can define the boreholes wherever you have them from your report, and you can generate the soil massif, and then automatically every concrete foundation gets the soil stratigraphy that is that acts below that foundation. So it's a specific soil profile that you have, and that will be used for every foundation and relatively comfortable. You don't need to think about you don't need to calculate somehow how the soil layers will be for the other positions. You can just consider it from the massif. Okay, so now we will go to the program. Here we have the model from the last concrete foundations webinar, and that it was calculated with the first method, with the simplified way, and we have here the concrete foundations folder, and we can see we also have geotechnical analysis folder, and we have here just the boreholes, so they come with the add-on concrete foundations. And now we can go here, and this is the dialog where you can define foundation settings, and here we have one tab for the soil properties. And so this is the single layered definition type. You quite easy can say which soil shall be placed below the foundation, which is next to the foundation, and which is on top the earth covering soil. This is the one way. Then you have the multi-layered borehole, as I mentioned. There you can directly from here create a new borehole. You could also use the other way, like we did before. So let's say that we have here a sand and a layer of clay, and again sand and then a gravel. And maybe it's 1.50, it's just an example. Then 1 meter thickness for the clay, 5 meters for the sand, and then we have maybe another 12 meters for the gravel. Okay, we can say OK, and then the borehole is created. We can see here is an object existent, and you can assign it here. And if you would have more, you can select which one, and you get this table as overview, but the data is filled in the borehole dialog. So we can say OK. Yeah, the results are deleted then. Yeah, what we see here now is the static analysis for the superstructure. Only the concrete foundations results were deleted. So here we see our borehole. Yeah, it was created, and these foundations now would use this borehole. And now I would like to show the other input option. We don't go here, therefore we have to activate the geotechnical analysis add-on. We go here to add-ons and activate our geotechnical analysis, and then it's okay. It exists, and we will have then the soil massif here to so that we can use it. It is relatively slow. It's probably connected with sharing the screen. It should be done soon. Okay. Yeah. So now we have here the soil massif, and we can create a new soil massif. But I would like to show it to you with a model I have prepared to save some time. We have it here. It is already calculated. So here in this model we can see we had several boreholes from geotechnical report. The input was done, and our soil massif is created. And let's have a look into the foundations. Soil properties. Here we can see now that the definition type soil massif is used, and we do see here now the soil layers for foundation at node number 10, and we could also check it, for example, for node number 1. Now we see that the thicknesses of the layers changed, so the program finds the soil profile for every single foundation as we spoke. You can also display the visualization for all the foundations in one table, and you can see then from which thickness up to which thickness exist in the whole model. So we have foundations that have a clay layer that has a thickness of 0.76 up to 2.48 thickness, and so on. And yeah, this is the summary of all the foundations that exist in this model, and you could also look at detailed at separate for the foundations nodes. Okay. So that's it. Yeah, and then you have the input prepared, you have the soil massif, and then there are two little things that should be taken care of in the current state. There's one thing, the soil massif is here, if we go, has the setting that it is the soil will be represented as 3D finite element method. So this is a solid, and if you want to just calculate your superstructure and use it for getting the soil properties for the foundations, then you don't want to analyze the full 3D body, and therefore you can select here the solids and go on edit and say deactivate for calculation. This is one important setting, as it saves some time if these solids are not calculated, and it is not required to do the 3D analysis for the soil if you just want to have the info about soil layers for the foundations. This is the one setting that you should take care of, and the other one is that also here this load case that I did show before would be generated from the program. So if you see it, you can just delete it. It is not needed here. This will be in the future not happen anymore. We are working on this topic. So these are the two things in the current state that should be taken care of, and after that you can go here on concrete foundations, start the calculation, and then these foundations will be analyzed and designed. Yeah, but this is a topic, then further information you can see in the previous webinar on these design checks, and yeah, that's it for this introduction to the ways of modeling the soil properties. Okay, then it shall be it, I guess. Then we can go back to the slide. Here we go. We want to have the outlook, and yeah, these are the next development steps for our add-on geotechnical analysis. In the nearer future, we will release the slope stability analysis with using the phi reduction, so we are able to analyze these situations, to check the slope stability. We are looking forward to provide this feature to you. Then we will also, now we have the 3D analysis and we have the advanced half-space method. We are also working on providing the subgrade reaction method to you. It is another option to represent the soil behavior as a surface support, and it's not an iterative method. And we will present further material models for our finite element analysis for the soil, and therefore we are working on the CAM clay model so that we can provide this to you, and also the jointed rock model. Yeah, I think these are the next steps. Beside that, we are of course working on improving the solutions we already have. Yeah, this shall be it. Yeah. Okay, then I would give the word back to you, Andreas. I do thank you for your attention, and yeah, Andreas, you can take over the screen. Thank you very much.
Thank you, Juliane, for your nice presentation. At the end of the webinar, I have different hints for you. You can book our online courses. For example, the Rfem 6 course, that's a course for beginners. Then the Eurocode 2 course for the reinforced concrete design with Rfem 6. The Eurocode 3 course for the steel design. Eurocode 5 for the timber design. Eurocode 8 for the earthquake design. For more information and prices, just scan the QR codes here, or you can click at the links at the bottom. You can download the slides from the same page where you can find the recording. In the next days, you will get an email with a link to that page. An additional hint to the online courses, you can get such a single course for free when you send us a customer project, and after the publishing of your project, you will get such a course for free. Just write me an email to info@dlubal.com, and I will write you what data I need from you. It's not much work for you. Yeah, a hint to our free online services, for example, the Dlubal community. You can get in contact with us or other users. You can ask questions, and we or other users will help you. Then there's the geozone tool for the determination of wind and snow loads and also earthquake loads. Then the cross-section properties. You can download for free models of Rfem, R-star, R-section, R-wind, and you can use it maybe as template for your project. Just if you don't have our programs already, just download the 90-day trial version. It's a full version with all add-ons. To explore all our free services, just scan the QR code here, or you can click at the link. More information can you find on our website, dlubal.com. For example, the knowledge base articles. You can ask questions to our AI assistant Mia all the time, 24/7. And she's also available in the programs, not only on our website. Okay, that should be also all from my side. I thank you for your attention. Thank you, Juliane, for your nice presentation. I wish you all a nice rest of the day. Bye-bye.